Hello, thank you for watching this video. So in this video I'll be doing question 9 of number 1 2021 question paper mathematics paper 1. And these are derivatives. Yeah, so we'll be deriving here. So I'll start at 9.1. So 9.1 reads as follows. Determine f prime from first principles if it is given that f of x is equal to 2x squared minus 3x. So they're asking you to find f prime, the derivative of f, if it is given that f of x is this. And they want you to find that derivative using first principles. What do they mean when they say first principles? It means that you use the derivative definition, which you should all know that f prime at x is the limit as h goes to 0 of f at x plus h minus f of x all over h. That is the definition that they're talking about. So when they're saying find the derivative from first principles, this is what they mean. Use this definition. So, so from this definition of yours, we're taking the limit of this thing here. So you have f of x already because you're given f of x is equal to 2x squared minus 3x, yes. So now, the first thing that you should do, you should try to find f at x plus h. Then once you find it, then you can substitute the entire thing on this formula, on this definition of yours. So you say, okay, f at x plus h is equal to 2 into x plus h squared minus 3 into x plus h. What do we have? Simplified version, 2 into x squared to expand this, plus 2hx plus h squared, right? Minus 3x minus 3h, multiply by 3 inside this. Then you come simplify this. F at x plus h is equal to, this time this, 2x squared plus 4hx, this time that, plus 2h squared minus 3x minus 3h, right? So if you look at this, there are no like terms here. There are no like terms that you can group. So you substitute your f at x plus h here, and your f, which is this here, and then you simplify. So you say, okay, f prime at x is equal to the limit as h goes to 0 of f at x plus h. What is it? F at x plus h is this thing here, which is 2x squared plus 4hx plus 2h squared minus 3x, right, minus 3h. So this is your f of x here. So from this f of x of yours, subtract your f. So from this f at x plus h, you subtract f of x. What is your f of x? It's that thing over there, which is, I'm going to cross over to the other side. 2x squared minus 3x. Oh, this is all divided by h. So I'm going to use another ink. This one is failing me. So from here, you remove your brackets. You say, okay, f prime at x is equal to the limit as h goes to 0 of what? Of 2x squared plus 4hx plus 2h squared, right? Minus 3x minus 3h minus, this time is that, minus 2x squared plus 3x, all divided by h. So from here, you group your like terms. You see this one and that one go away. See, this one and that one go away. So you're left with this. So you're left with f prime at x is equal to the limit As h goes to 0 of what? Of 4hx plus 2h squared minus 3h. Yes, minus 3h. Then left with this 1, 2, 3 things. 1, 2, 3 times here. So what do? From here, all over h, of course. So from this point, take out the common factor at the top, which is what? It's h. So you take out h as a common factor. So you have f prime at x is equal to the limit as h goes to 0 of h into 4x plus 2h minus 3, right? All over h here. So this and that go away. Once you cancel this, we're left with f prime at x is equal to the limit as h go to 0 of what? Of 4x plus 2h minus 3. That is what we're left with. Then the next step is to allow h to go to 0. So we allow h to approach your 0 then. So if you allow h to approach your 0, what do you have? We have f prime at x is equal to 4x plus 2 into 0. Allowed h to go to 0 minus 3. Therefore, f prime at x is equal to 4x minus 3. That's your derivative from first principles, which is using the definition. So you're done with this part. So I'm going to isolate this. So now we're doing 9.2.1. So determine the derivative of y with respect to x if y is equal to 4x to the power 5 minus 6x to the power 4 plus 3x. So they wanted to find the derivative of y with respect to x. This is the easiest. You are praying for this. You're always praying for something like this. So you want to derive your y with respect to x. So what do? Say, okay, the derivative of y with respect to x is equal to, what is the derivative of this thing? Go to 5 times 4. What is 5 times 4? Is 20. Then you subtract x, subtract 1 from the exponent, which is 4, right? Minus 4 times 6, that's 24. So 24 x, then you subtract 1 there, so cubed. The derivative of this 3x here is 3. You're praying for this one. You're home there giving you this one on your final exam. So you're done with this one. So I'll move to the next one. Okay, now we're doing 9.2.2. So determine the derivative of this thing here with respect to x. They wanted to find the derivative of this thing with respect to x. So for grade 12, when you look at it, you know that you can't derive if you have any form of root inside, whatever. And you can't derive if you have a variable as a denominator. You must first sort those problems out. So what do? Let's fix our problem. So you write this as a power form, right? You remove this cube root here, write it in the form of a power. So what do you have? You know that you have 1 here, right? So this is going to be x raised 1, then you divide by 3 over 2, right? Plus 1 over 9x squared. So we have removed our cube root there, right? So we're good here. Okay, we're good to go. But here we have a problem. We have a variable as a denominator, which is our variable, which is x squared. So we should take that x squared to the top, what we have. Say, okay, we have x raised 1 over 3 over 2, right? Plus 1 over 9, x raised negative 2. So at this point, you're good to go. So now you want to find the derivative of this thing with respect to x. So your derivative now, which is this thing here is equal to, which is this thing is equal to derive this, say 1 over 3 times 1 over 2. Or you can say 1 over 3 times 1, right? So you have 1 over 3 x raised, then you subtract 1 there, minus 2 over 3 over 2, right? Plus minus 2 times 1, so you have minus 2 over 9. X raised negative, subtract 1 there, negative 3. So this is equal to 1 over 6. X raised negative 2 over 3 minus 2 over 9. X raised negative 3. Then you take these guys with negative signs to the bottom. So you have 1 over x raised, 1 over 6x raised 2 over 3 minus 2 over 9 x cubed, right? Therefore, the derivative with respect to x of cube root x over 2 plus 1 over 3x all squared is equal to what? It's equal to 1 over 6 cube root of x squared, right? Minus 2 over